Hello, Professor. So we are Group 2. My name is Anurag Bhattacharya.
Hello, Professor. My name is Raghav Thakkar.
My name is Kazim Udukale.
Hi, Professor. My name is Pradyumna Donikal.
I am Tingley.
So today we will do a presentation of our live code execution for the data analyst of the bike thieves database. So first off, if we run this code, we're loading the database into a data frame and then finding basic statistics about the database. So Raghav, can you run the first cell?
Yeah.
So we are using Google Colab. So we're using Google Colab as our technology to do the data analysis. So I'll run the first cell. So here we are describing, in the code, we're describing the different statistics, so like the column values, the different columns, the shape, the main statistics, the data types. And here we're displaying, in this code result, we're displaying the first 5 records of the data frame. Next, we will pass it to Donikal.
Yeah, can you run the script? So in the first 3 lines, we're checking if any null values exist in occurrence day of month, occurrence day of year, and occurrence hour. And then after that, we're basically displaying the frequency of bike types based on year. This helps us determine the relationship between the frequency of bike types versus the year. Okay, can you go down? Okay, so here we're basically trying to display the frequency of bikes on year, month, and then the mean cost. This table helps us determine the relationship between the cost of the bike and the year and the month which it was stolen, say.
Next up, we have for the above data frame that we created for the frequency per month and year, we're finding main statistics. So we found different basic statistics like mean, standard deviation, minimum, maximum, and quartile statistics. Also, we found the mean of all the numeric values, the correlation, and lastly, the mean of all numeric values grouped by bike type. Next one, and that's the same for me. And this in here, we're getting the count of all the statistics in the whole database. So how many items are there per column? And also we're finding if there's any missing data in each column. And if you scroll a little bit down, we can see that bike make, bike model, bike color, and cost of bike has some missing data. And for that, we are dealing with it in future code.
Okay, can you run that cell again? Okay, so here we're using Matplotlib to plot a histogram to portray the frequency at which bikes are stolen in a particular month of the year. So this is supposed to help us determine in which month bikes are often stolen. Okay.
So in order for future to provide valid data for the future analysis, we are checking the missing value first. As you can see here, we have some missing value for bike make, bike model, and bike color and cost of bike. So the rest of code are checking missing value. What is the unique? Scroll down, please. Yeah, this part is checking what is the unique value in in those columns, because some kind of column may have some strange values, like such as please scroll down, please, a little bit down, a little bit up. Yeah, stop here. Let me see. Bike make. I think you have to scroll a little bit up. Bike make. Oh, it's strange. It's not here because we have some strange value like a non-make in bike make. So if we just replace any check missing value, maybe it is not enough to handle all the missing values. So we use unique function to check if there is any value should be considered as missing value. Scroll down, please. Next step. Yeah. So after checking all the string values, we start to deal with missing value. First, we try to replace those missing value to NNA as values, so that we can use this kind of thing for our future analysis. First, we found for backmake the highest frequency value is OT, so we are replacing the missing value as OT. And for the next one, we are do the similar thing, but we are replacing the missing value with the hybrid. This is the highest frequency value. And the next one, we are checking the color, and the highest color is black. So we are replacing the missing value as black. And the next one is the status. For the status, we just want to double confirm everything has been handled. So we check our missing value too, and replaced our missing value to be the stolen, because this is the highest frequency value. And the next one, please. And we're also trying to replace the missing value for the cost of back with the mean, because this is how we deal with the number. And because we have some string value for the month, day of week, and report day of week as well. So we are trying to replace those string into a number. In this way, we can use all the data for the further analysis. Scroll down, please. Now every missing value has been handled. So we are now converting category to a number. In order to do this, we are using encoded. We are using encoded to encode all the string into a number. So you can see here in our table, if you scroll to the left, right. Yeah, to right. The end of the right. Yeah, you can see here we have the neighbor. For example, we have the neighborhood name encoded and by color encoded. So this is how we handle the string, the category value, to convert them into a number. And after this, we are checking if there is any imbalanced value. As you can see here, we have most of value are 1, which is the stolen value, but we still have some value with very small amount of value, which is recovered. So in order to handle this imbalance, we are trying to use the smooth function. Scroll down, please. Yeah, scroll down. Yeah, scroll down. In order to handle the imbalance value, we are using smooth function to do the oversampled function to increase of our imbalance value, so that we can use the handled imbalance data for the further data analysis. And I think this is my part. Yeah.
So like basically now we are standardizing the data. So we use a standard scalar function, standard scalar, and whatever the oversample data we get, we just transform that all the data, and we use the data frame to oversample the data and just display the status encoded, and like here you can see in the column. Now whatever value we got, we just normalized whole the data process using the panda, And you can see that we are converting value, normalizing the value using the standard function, and you can see in the column as well. Yeah, so yeah. Yep. Now, yeah. Now, can you Tingley, please?
Thank you. So after we normalize the data, we start to split data for the training, and we split our data with 80% as training and 20% as the test. So the number is on our is in our result, as you can see from here. And the next one is we try to select some features which is most important to our database data set. So we are using we are checking the score, and we are trying to calculate every score for each of the column. So in order to select our feature, please scroll down. Scroll down, please.
Yeah, sure.
Yeah, this is this one with all the zero, that is only provide a structure of the table. And now we are trying to calculate the score for each of the column. And you can see there are values in for each one, and we are selecting some value with highest with higher number. We didn't select the value with 3 or more zeros because for me I think that is less relevant to our data. So we only select the occurrence day of month, cost of back make encoding and the back model, back color, and location type. Only this.
So next thing, using our training data, we have gone through the steps of creating a decision tree, and then we can see that from the accuracy, which is right now 0.94, around 0.95 basically, we can see that this is so far our current highest accuracy model. So at the moment we are planning to use our decision tree model as our API flask. So then we select a different feature selection to see the different data for the first 5 records. Next, Kazim will explain the confusion matrix.
Yeah, the confusion matrix is a two-dimensional array that is used to analyze how your model is actually showing how the ones that the positive and the negative ones. So if you look at from this confusion matrix that we have here, it is showing that we have a true positive of 4,814 to a false negative for 201, and we have a true negative of 4,729 to a false negative of 378. So which is fairly good, and is okay. So, and this diagram is just the pictorial diagram of the same analysis that we have upstairs, and it is using Seaborn to do the same thing. Okay, scroll up. So in this place, scroll up. Okay, this is the ROC diagram. So the ROC, in most cases, when you have a two-dimensional category, like in this case, the common errors is that you probably make a false positive prediction, or you make a false negative prediction. A false positive prediction means that you predicted that something is going to happen and it did not happen. And a false negative means that you predict that it's not going to happen and it will happen. So in most cases, you need to find the balance depending on the severity of the analysis you are doing. Take, for example, you are looking into somebody collecting a credit. You want to check if somebody is going to be able to pay a loan. So you want to give a loan facility to a customer in a bank, and you want to predict if he will be able to pay the loan. So you have to make sure that, okay, you are in a safer side. If he doesn't pay it, then you look at the implication. So the implication will determine which one is preferable between having a lower false positive or a lower false negative. So from this diagram, it is showing that if you have a very good, if your model is very good and is predicting, is doing a very good prediction, then the curve is supposed to go from 0, 0, that is from bottom left straight up to bottom top, then curve from that edge straight down and go to right top. So this diagram is showing that our model is almost perfect. So it's making a very good analysis and a good prediction for us. So that is what we have here. So Anurag will continue from here.
So here we're doing the logistic regression model. So we're using the training data and our feature selections and doing our logistic model. So if we run the the full code, I'll scroll down a little bit. So here we can see, so we created our predicted score from a 10-fold run, and we can see that the accuracy isn't as great as our previous decision tree. So we decided to not choose this. And we can run the test data again against the new model, and we created a new confusion matrix with different, now this time it's a 3-dimensional confusion matrix. And Kazim can explain the ROC for the decision tree, for the logistic model, sorry. Kazim?
Kazim, you're mute.
Sorry, sorry, I was talking. So if you compare the ROC of this one to the one of the decision tree, we see that the decision tree is much better, because the decision tree, the ROC of the decision tree was almost perfect. So this one is not very good. If it is good, it is supposed to go almost straight from bottom left up, almost straight up to top left, then curve and go to top right. So this is not a very good representation of the data. So that is why we still insist that the decision tree is better for our data set than this logistic regression.
So now we have concluded that we're gonna use the decision tree. So we use JobLib to dump the model. So first we are going to dump the model, and whatever feature selection we have, we're gonna use that columns, and we're gonna use the dump the model using of that columns as well. So when I run this code, all the models will be dumped to our Google Drive. As you can see, the model has been dumped. Now let me go to the Google Drive, and as you can see here, the model has been dumped. Yeah, so this model has been dumped. I'm going to download these models, and yeah, so I have downloaded those models. Now I'm going to run the Python Flask API to check our API is working fine or not. By running this Flask API, you can see now the server has been up and running on this following URL. So let me open the Postman. Yeah. So as you can see this URL, so yeah, this is perfect. Now, as you can see in this like feature selection, we have used this and we have encoded this bike make, bike model, bike color, bike type into the numeric value. So we're gonna pass those value here and I'm gonna just run this one. You can see the prediction. It's predicting perfectly based on our value. And that's all, I think. That's it. Thank you.
Thank you.
Thank you.
Thank you.